Hello, so now is the second part of the division that we started last time. Last time we did a example on a decimal to understand or to revise what I should say, the steps that needed to divide two decimals. Exactly same steps will be used in binary. The only difference is here we have um, binary number. So and binary number is 0 or 1. And the quotient will be 0 or 1. And remainder will be 0 or 1. Okay, and there will be subtraction. Subtraction is a little different for binary. You know that when you subtract something, as you've seen in the previous videos, that you calculate as 2's complement of the second number and then add it to the first number. So that's all. But anyway, let's take a look at one example, and then we I solve it like this, but let's look into first one just while we have this algorithm here. We look at this division. Okay, number is of this is 4-bit, and this is 4-bit, but there are 0 0, so I'm just considering 2. So this is 2, this is 11. Okay, what happens? Pick first bit of dividend from left. So we pick the first one. Let's remove these ones. Okay, we pick the first bit, and what happens is we compare it to this number. Okay, well, let's take an example first, because I think a lot of videos I've seen who try to explain this in words, but it's hard to understand it in words. It's best to have the actual numbers written there. Okay, so let me explain the hardware. The hardware is similar to the shift and add or the serial multiplier that did in a previous video. It's a similar hardware, okay, except that now we have a subtraction happening here. So we, again, you know how to convert an adder into subtractor. All you have to do is have a 2's complement of the second number. So this will be dd minus dv, so it will be 2's complement of this, and this will be carry in as 1. So all this is done inside this block, so I'm calling it a subtractor. Okay, then let me put, I missed one. And these blocks that I call q, second, let me call this as dividend and remainder. Some videos you will see on internet and people explaining it, they will go through one step where they use this different bit, this different bit, but I'm going to explain you the final one so that it's not confusing. And trust me, it's not confusing. It is definitely takes few steps. It takes pen and paper to understand it. So the hardware is these blocks that you see, these are registers. We will look into registers in the under sequential section. But registers are used to hold a binary value, to store a binary value. So dividend is 1011, but this is a register where you will see that we denote it with this symbol. So we keep that 4-bit here, store it. It doesn't change unless you want to change it. And there are ways you can change it. Okay. Then quotient we try saving on this register, means it will hold the value. Once we change it, unless we want to change it ourselves, it will stay there. Then subtractor output is always available. We can decide on it. But when we actually want to use it in the algorithm, we just enable the storage of this value onto this register. Understood all the components? Then what's happening is, in terms of how many bits of what, let's say we are using an ALU or a core that is 4-bit. Again, early the one you want to build would be 32-bit. In that case, this will be 32-bit long DV, 32-bit long Q, but the product or my division is always double of that. So that will be 64. It's very difficult to put that long boundary numbers here in this example. So what we do as a simple, we scale down this processor. We say it's just a 4-bit processor. So what happens is our main registers are 4-bit. This is 4-bit. This is 4-bit. This is important. This entire thing is 8-bit. And I call it dividend and R because we will use this whole register to store both values, and we will shifting them to create place for the remainder. So only the top 4-bit. So if this is the MSB, this is the LSB, top 4 MSB bits are fed back to the subtractor. So these 4 and these 4 are always subtracted here. Result is available. It's not going to be written onto this register immediately, only when we enable it. That is the whole circuit we are using. And there's only one subtractor. So we are doing multiple subtractions. So you can imagine that we will shift results in subtracted, then shift, then subtracted, sort of like that to serially use this hardware, which means it's going to take longer. Let's do the first step. So very first step is initialization. We load the divisor, we load dividend. So dividend, but the way we load is, let's put our divisor is 0, 0, 1, 1. A dividend start with here. This, but the actually zeros are filled here. Our Q is a register maybe initialized with 0, but every time we will update this one too based on this algorithm. Here is the fourth thing, exactly same thing I mentioned here. This is the first step, initialization. DV, I call them a reg, these are registered, but whenever I say DV, Q, DD, I mean registers. So 0, 0, 1, 1. This is bit 3, bit 2, bit 1, B0. DD reg, again, MSB 4 bits 0, then the actual DD is here. Q reg is initially 0, 0, 0. Okay, there are 4 bits. Sorry, in the dividend there are 1, 2, 3, 4 bits. So we need to keep repeating these bits here until we go through all of them. And then our division is complete when we have processed all the bits. What we do the very first time? Very first time, we bring the first bit of this into here. It's the same thing as calling, okay, let's pick the first bit of this. See, instead of saying that let's pick the first bit, this is where whenever it comes into this area in this segment a bit, it will be getting into our action of division, you call it. So first we bring this, work on this means bring it here, means you're shifting this register to the left. So this is this register. What we are doing is we are shifting every bit here. So you can see that this comes here, this comes here, this comes here, and this comes here. This value is thrown out of the register. And you can see this here, this here, this here. and 0 enters into the rightmost side. That's how we're shifting the entire register. So when this one comes, now I will not have this video, will not be up, I will not have this picture here, will not be updating that one. But whenever, now think about that, okay, this is the component. Let's use pink. This is the component, this will be added, and this doesn't change. And this will be, since it's, as I mentioned here, dd minus dv. dd, which is this, it's top, and dv this minus. So our very first step is, okay, bring the first bit, so we brought by shifting it. Okay, so we bring bit 3 of dd, bit 3 of dd to compare with divisor. Now is the first step, if you remember. So we are checking if this bit, again I have to go back, if this bit is smaller than this or not, this step. So we are doing on the side this division. If you remember, the way we do the division is 0, 0, 0, 1, 0, 0, 1, but I have done this. There are two ways you can think of. If I tell you, actually I should tell you the right way so you're not confused. So what happens is, your top is 0, 0, 1, bottom you take 2's complement of that, which is 1, 1, 0, 0, which is called 1's complement. Are you flipping all the bits, and then you're adding one bit, that makes it 1, 1, 0, 1, and then you're adding now you're adding things, so become 1, 1, 0, carry 1, 1, 1, which is this. There's another way you can do quick division. So you say 1 minus 1 is 0. 0 minus 1, you cannot do that. So you bring a 1 here, which becomes 1, 0. Okay, 1, 0 is 2. So we bring from here, we makes 1, 0. You have 1 left. From here, you need bring 1 here, it becomes 1, 0. But you have 1 left. So from 1, 0, which is actually 2. 2 minus 1 is 1. There's 1 left, 1. There's 1 left, 1. So either you do a typical method, or you do kind of a mental subtraction. So you can do quickly. Instead of taking 1's complement, add 1, you can do this. I hope you have understood this method quickly. So again, what I did, first one is 1 minus 1 is 0. But second one, you cannot subtract 1 from 0. So just like decimal subtraction, you borrow from here. When you go here, there's nothing here. So you go the next step. There's nothing here, and then here. You assume there is something here. That 1, first you bring here, becomes 1, 0. That is 2. But so from here you bring 1 here, so that leaves 1 here. From here it makes 2, so from this 2 you bring here 1, so it leaves 1 here. And 1, 0 is 2. So 2 in decimal, by the way. I shouldn't say, I say 1, 0. 1, 0 minus 1 is 1. You had 1 left, 1, 0, 1. 1 minus 0, 1. So anyway, these two numbers are exactly same. So you can see, again, if you remember on this chart, when you do subtraction on the side, you take a look and say if it's less than 0, all you do is, if you remember in the decimal case, you put a quotient 0, which is the same 0 is also there in the binary. So you put 0 on it. And this is exactly what we are doing. So this is a quotient. And you see that after this subtraction, we have not changed dd reg. So this value has not changed. Even though we brought 0, 0, 1, we did a subtraction, but based on the subtraction here, we found out that the most significant bit is 1, which means it's negative. So even though numbers are unsigned, but this subtractor is really the most significant bit is a signed bit. Okay, so what we do is where are we? So after that we put quotient. So what we do is, it's getting a little confusing for you. So what we put a new bit, it's like moving the Q reg to left. So you put 0 bit here. So we put, and the old bit is gone now. So this bit is here, this is here, this is here. This is actually our quotient now. It's not the initialized value. Because the difference was, we found the difference, and since it's negative, bring next bit of DD and set Q0. So we set Q0, and at the same time as we move this one, now we are moving this thing, and again by left. So this one comes here, this one comes here, this one comes here, and this bit goes here. This first bit goes as a second bit, this here, that's gone. This is a new bit we brought in, 0. This was first, that original 0 is gone, so these are extra, and this is our first quotient. So it's 0, you can see here. It's oops. Okay, first quotient 0 has arrived here. I hope it's clear. If not, stop the video here, go back, take a look at this, and based on that, start writing these things. It's very important that you understand each step. So one bit round has finished after initialization, and there are 3 steps. You subtract, and the difference, you're not loading the difference, you're just figuring out if it's negative or non-negative. Mean is less than 0, smaller. You cannot divide, you have to bring the next bit, and what you do is you bring the next bit. Now it's 0 0 1 0 as opposed to 0 0 1, and your quotient is 0. All right, next let's go to the second step. Now exactly same thing. Now we have new value. This doesn't change, so this minus this. Now leave it a homework for you to figure out that subtraction is this one. This result of 4 bits are here. Suggest that it's negative again, MSB. What do we do with that? Well, what we do is it's negative, and the same thing. Negative means we put quotient another 0. So what we are doing here is same thing. This bit has come here, previous new quotient, and we have added new bit 0 because it's negative, we cannot divide right now, and we bring the next bit here. So what is this? This thing has gone here now. Now I'll just show this bit, and this bit is gone. So move, this bit is gone. Same step, there's no difference between the first one, second one, both have generated 0 quotient, and this one here. You brought first bit, not enough. You brought second one, 1 0 compared to 1 1, still not enough. You put 0, and now you go to the next one. And when the next one, it becomes 1 0 1, and you will see here, now it's 1 0 1. So what you do this time, so this one done, so you shifted it. Now we come into the next step, and we're doing this minus this. So result is this. Your homework, find out this minus this is this. This time this is 0, a positive one. So what you do is, since it's a positive one, Now you can divide actually. So the positive one loads subtractor output into DDR. Now, since this bit more is a positive number, we actually loading this value onto this whole thing. So now you will see this thing, the this thing, the subtraction. So you see, we have not shifted it. So instead, what you have seen that the subtraction output was 0, 0, 1, 0. So what we have done is, this number was 1, 0, 0, 0, as you can see here. Our new, based on this minus this, a new subtraction is appeared to be this one. So we have loaded this value onto this one. So you can see that. Now this one, exactly this one. So it's not a shifted version of it because we don't need to shift. We actually need to perform this subtraction. So 101, now it's bigger. So 1, 1 is always 1 or 0. That's the good thing. It's not a 1, 1 times 3, 1, 1 times 4. No, it's a binary 0 or 1. So we put 1, you 1, and then you subtract, and your answer is 1, 0. I'm just focusing on this one. So you can see that our result is 0, 0, 1, 0. And that is here. So now our quotient, we put 1 here. Because quotient this time was 1. It's this one now. 1, 1, 1 times 1, 1. And remainder is 0. So you can see that our remainder is here 0, 0, 1, 0. This is the remainder of DD. Now this entire thing acts as a new DD reg. Now you see that if you look at our number is really now this. These things are gone. We have divided them. It's really 1, 0 is there, 1 is up there. And next step is really bring this into here and then compare with 1, 1. And that's exactly what we are doing here. So we put the result as 1. Others we have shifted. Remember, first question was 0, second 0, and now is 1. This is gone. Now in order to bring the next bit in action, so we have shifted this thing now. This gone. Because we have to pull the next bit, right? The rest is. Now, again, same step. You subtract this one minus this one. So use 0, 1, 0 minus 0, 0, 1, 1. You subtract is your homework. Figure out the subtraction result, this one. It's similar to this step. This is positive. So since this one is positive, what you do, you put a quotient 1. So you shift in a quotient. So this one is here now, this one is here, this one is here, and you put a new quotient, 1, 1. And subtraction output is 0, 0, 1, 0, 0, 0, 1, 0. And the previous, those lower bits are this one because we have really processed all the bits. So this is our final DD remainder reg. This is quotient. So our quotient final is this. Our remainder is this one. And that's what you see, what we have here. Remainder, and this one is our quotient. This one was our dividend, and this was divisor. Okay, so we have finished it. I really hope you have understood it. I hope I have done a good job or better job in explaining you this. It's very hard unless you really go live and explain it, you don't know. But if you have any question, let me know. That's it for now. See you in the next video.